What's up, math fans? Because I'm going to use exponential functions to explain the graph of a logarithmic function. All right. So I told you this story. One of my favorite movies is called Pay It Forward, where a boy decides he's going to do a favor for 3 people, and he's going to ask those 3 people to do favors for 3 people, and then it kind of spreads really, really fast. So a function to model that would be, well, the boy I would call phase 0. So that's just one boy. All right. Actually, I'll do this in black. That's just one boy, and then phase 1 is when he helps the 3 people. So 3 people are being helped. Okay? Now, phase 2, those 3 people have to help 3 people, so 9 people are being helped. Then those 9 have to help 3 people each, 27 people are being helped. Alright? And then it grows really, really fast. I think we get to 81 here, etc. That's what we call exponential, when the growth rate is shooting up. And we can plot that. So why did I put negatives? Because just in case it's not a real life situation and you just want to look at the math behind it, what if I put a -1 here for my x? So I'm going to represent this story as y equals 3 to the x power. My base is 3 and the x is the number of trials. Again, 0 means 3 to the 0, and anything to the 0 is 1. 3 to the first power, if I plugged in 1 for x, is 3. 3 squared is 9, etc. So it works. Also, I can put negative numbers, 3 to the -1. Hopefully you remember, if you have a negative power, that flips the base, making it 1 over 3 to the +1, which is 1/3. So it really turns it into a fraction. It doesn't give you a negative result. Here, this would give me 3 to the -2, which is really 1 over 3 squared, which is 1 over 9, etc. So now if I plot that, -2, 1/9 is really, really small. -2 is here, but 1/9 is really, really low, close to the x-axis, but not touching. And then -1 1/3 is also pretty small, but not as close. Now 0, 1 is usually a very popular point because anything to the 0 is 1. So usually, no matter what the base is, when I have a 0 exponent, I'm going to get 1 here. The only time I don't get 1 is if there's a coefficient next to the base, like your initial investment when I was talking about compound interest. So this number is the initial number. Let's see here. 1, 3, 1, 2, 3, 1, 2, 3, excuse me, 1, 3 is here. 2, 9 is going to be a lot higher, and 3, 27 is going to be really high. And so I'm not doing an exact graph, I just want you to get the idea. I start from really, really low, and then it starts to grow really, really fast. Going left, if I kept adding more negative numbers here, this would get even closer to 0, but it would never touch. And when a graph approaches a line but never touches it, that's considered an asymptote. And I will probably touch upon asymptotes in future videos, so don't panic, but yes, you can pause and Google. Here is a nice example of an exponential graph. Now what you should understand is that a logarithmic function is the inverse function of an exponential function. Now, do you remember what we said about inverses? You switch or replace the x and the y values. I do have a video out about inverse functions. So, graphically, inverse functions are actually just mirror images over this dotted line, which is the line y equals x. So all the y's switch with all the x's, so it's a mirror image, all right? So the graph here is going to look like this. That's what my mirror image would look like. If you can tell, I try to use purple so you can see different color, all right? So this graph is the reflection, is the inverse, and it's the logarithmic function. Now let me label it so you have actual labels. The black one is y equals 3 to the x. And now, I'd like to call your attention here for a moment. I'm going to take y equals 3 to the x and I'm going to switch the x and the y. So the reverse is x equals 3 to the y. But usually when I graph stuff, especially on a graphing calculator, there's that button that says y equals. So I need to get y alone, and that's why we invented, or I didn't invent it, but that's why logarithms were invented. So it helped you isolate an exponent. So I can rewrite this, and if you saw my intro video on logarithms, you know how to rewrite this. Base, exponent, answer, remember that? So I write log base 3 of x equals y. Look at that, I isolated my y. So log base 3 of x equals y, that's this purple graph here. And there are specific points. It wasn't a random sketch that I did. There are very specific points here. Do you know how to find them? You just switch all the points. Isn't that what inverse is? You're switching the x's and the y's. So here's my points. 1/9, comma, -2. So if you look here, my 1/9 is really, really close to 0, so it's somewhere down there. 1/9, -2 might be somewhere around here, right? That's 1/9 -2, and then 1/3 -1 is right here. I'm a little off. And then 1, 0, so that actually I missed. So this here would be considered 1, 0, right? There's my x-intercept. And then 3, 1, so 1, 2, 3, 1 is here. And 9, 2 eventually is going to be somewhere further out there. So this grows really, really quickly. This grows really, really slowly. Those are my inverses, all right? And that's pretty much all you need to understand is you got your black curve, that's your exponential, and then your purple curve is your logarithmic. Then there's different things that you can do with these curves. For example, if you get an equation where you have, I don't know, y equals log base 3x plus 1. So if you remember, I taught this with absolute value graphs, and I also taught this with parabolas. How do you move around the vertex? You remember finding the vertex of a parabola? And in order to do that, this number here shows the shift, a vertical shift. And then I even explained if there was a number inside, and that would be a horizontal shift. So, excuse me. So let's say I gave you something like y equals log base 3x plus 1, like that, and then a plus 1 on the outside. So this thing moves to the right one and up one, right? No, if you saw my old videos, and I know this is a review, so it's kind of foggy, the number inside is actually the opposite. So if I see plus 1, it actually means go to the left one, and then this is what you see, up 1. So what I would do is take my purple graph, my obvious point here is at 1, 0, so that would help me start to move stuff around. So I would move it left 1, I'll stay in purple, I would move it left 1, and then I would move it up 1. So 1, 0 becomes 0, 1, and then it kind of looks like this, okay? So I'm going to ask you to watch that video on finding the vertex again, because those rules apply to this, apply to absolute value, and also apply to parabolas. Those rules haven't changed. I think this will jog your memory. Y equals log x minus h plus k. You remember how I used to use hk for my shift? So this is my vertical shift, this is my horizontal shift. All right, thanks for watching. See ya.